Making Polyurethanes by Drake King. Overview of making polyurethanes. We will be exploring the history of polyurethanes, materials of polyurethanes, methods to make polyurethane, applications of polyurethane. Polyurethane was discovered in 1937 by Dr. Otto Bayer. He makes liquid diisocyanate and polyol to make a material that has very special properties. It was originally used to replace rubber due to the rubber storage in World War II. Polyurethane foam began to insulate aircraft in the 1940s. They discovered that this foam had very high abrasion impact and flame retardant abilities. In the 1950s, polyurethane foam became commercially available. It was used in homes to insulate. In the 1990s, due to the concern of the environment, chlorine-containing blowing agents were banned to promote the use of greener blowing agents. Today, polyols can be derived from vegetable oils, which make them more environmentally sustainable. There are three materials that are used to make polyurethane: isocyanate, polyol, and catalyst. The first material is isocyanate. It contains a nitrogen-carbon-oxygen group, which is very reactive to an alcohol. Diisocyanates are two isocyanate groups that are combined to react with the polyol. Two common types of isocyanates are TDI, which is toluene diisocyanate, and MDI, methylene diphenyl diisocyanate. Another isocyanate used is HDI. The reason they use that is because the TDI and MDI have an aromatic ring background, which causes it to darken when exposed to light, which will have a cosmetically unappealing product. Isocyanate is a petroleum byproduct, so they are looking for ways to make that more environmentally sound, looking for other materials to make isocyanates out of. This is the repeating unit for toluene 2,4-diisocyanate, and this is the repeating unit for toluene 2,6-diisocyanate, and this is the repeating unit of MDI. The second of the materials is polyol. It is a complex alcohol that contains multiple hydroxyl functional groups. Polyethers and polyesters are also used to manufacture polyols. Polyols can vary and are chosen due to the application. They can be made from different chemicals that give different properties. An example of this is phosphorus polyol have excellent flame retardant properties that give the polyurethane product excellent resistance. This is the chemical formula of the polyol dipropylene glycol, which is very common in the manufacturing of polyurethane. The third and final material used for the manufacturing of polyurethane is the catalyst. This is what is needed to kick the reaction between isocyanate and the polyol. Because they are too stable, they will not kick on their own. It controls and reacts the chemical reaction. The most common type of catalyst is a tetrary imine. Electrons from the nitrogen atom of the tetrary amine is donated to the positively charged carbon ions of isocyanate, and this causes the chemical bonds to cross-link, giving it a strong structural ability. Different catalysts can be used based on different types of reaction wanted. UV light can also be used to activate this reaction. Methods to make polyurethane. Polyurethane is made by mixing the diisocyanate with a polyol with two hydroxyl groups. Condensation occurs when the monomer of the diisocyanate and polyol react at each other's end group. They link up to form a urethane bond. The urethane linkages are made. Then after that, one large molecule is formed. The hydroxide group from the polyol binds with the nitrogen-based isocyanate functional group. This is a reaction mechanism of polyurethane. As you can see, here is the isocyanate reacting with the polyol to form the end chains react to form the urethane groups in here to form one large molecular chain. Polyurethane foam. Polyurethane foam, like I said earlier in the presentation, was discovered in the 1940s. It is the majority use of polyurethane in today's application. It is very flexible, strong material that has great insulation properties. It is also very flame resistant and high abrasion impact resistant. Isocyanate is mixed with water, urea linkages, and carbon dioxide gas is formed. Carbon dioxide gas expands the foam. When gas leaves the foam, it leaves a spongy, porous material behind. Isocyanate and polymol can also be premixed and have a blowing agent expand the foam. Here is the reaction of isocyanate and water. Organic material and polyurethane. Polyurethanes have a reputation for being bad for the environment. The isocyanate and polyol are petroleum-based, which, as we all know, is not good for the environment. We are running out of oil. Chemicals used in manufacturing polyurethanes are also very toxic to the environment. In recent years, plant oil is being researched as a replacement for the synthetic use. Polyols are being made with plant oil currently. Advantages of plant oil-based polyurethanes are that they are very biodegradable and therefore perfect for disposable packaging. The only bad thing about the organic material and polyurethane is that for engineering applications is that they eventually degrade. They will not hold their properties. Examples of plant oils are canola, corn, coconut, linseed, peanut, soybean, and etc. Applications of polyurethanes. There are four main industries of polyurethanes that are used in: automotive, furniture and bedding, appliance, and construction. It is used in these applications because it has very unique characteristics. The properties of polyurethane are high abrasion and impact. It is a very good insulator. It is resistant to chemicals, rot, and heat. It performs well in high fatigue heat. Here's a chart of the different percentages of use throughout industries. As you can see, at 25%, rigid foam, molded foam at 11%, flexible foam at 31%. So as you can see, it proves that polyurethane foam is used mostly in urethane and polyurethane. That concludes my presentation. Thank you for watching.